business for over 4 decades, working throughout the West Coast. We have numerous offices throughout the West Coast, and here's just a little overview of projects we've done.
So here's kind of our collaboration that's been with the U.S. Army Corps of Engineers Aquatic Plant Research and Control Program. So 81 to 82, the Sacramento Delta Water Hyacinth Planning. 83 to 84, Potomac River Hydraulic Control Demo Program. 88 to 90, the Ponderay River Dye Studies. 91 to 93, the Columbia and Ponderay River Trichlopure Studies. 89 to 99, Okeechobee, Seminole, and Kentucky Lake Hyperspectral Aerial Imaging Demo Project. 95 to 96, Lake Minnetonka Trichlopure Milfoil Study. 2000 to 09, various Washington studies. 2010 to 12, Ponderay River Acoustic Doppler versus Dye Water Exchange Study. And then 13 to 17, Flowering Rush Herbicide Trials. And then 18 to 21, Boat Curtain Flowering Rush Study in the Columbia.
All right, we're gonna first get into a little bit of product plant identification before we talk about our tools to control these plants. A few different types of classifications. So we've got vascular plants, that would include submerged plants. These are plants that grow underneath the water. We have floating leaf plants. These are lily plants, and they root on the bottom and they have floating leaves on the top. Then we have emergent plants, which grow on the margins and shorelines of a lake or river. And then there's also algae, which are single-celled plants. We'll talk about that a little bit more in detail if we have time at the end of the slides.
So we're going to start off with our submerged plants. So we're going to run through a couple of the common native ones here quick. So top left, we have common waterweed, number 1, also known as Lodia, Lodia canadensis. This is pretty typical. We see this in a lot of the lakes, rivers, and reservoirs that we survey. Sago pondweed, that's right in the middle. This really common plant, this can top out. It has a tall canopy to the surface of the water, so this generally causes problems for stakeholders with recreational accessibility. Number 3, American pondweed, top right, another native vegetation. It has more of like a kind of ovate shaped oval leaf, kind of a little more slender, and the leaves grow up to the surface pretty much where it is. Large leaf pondweed, bottom left, this is going to be a majority of the percentage of vegetation we see in a lot of the lakes in PNW. It's going to be really, really big leaves, up to like 7-8 inches long, and there's going to be a lot of it. And it'll grow right about up to a foot or 2 feet under the water, but it really doesn't top out that much. And then we have white stem pondweed on the right, number 5. Which has a kind of similar looking leaf to the large leaf pondweed, only it's just a little bit more narrow, and then the coloration usually is more green, bright green, as opposed to amphifolius, which is a little bit more brown in color.
So next are invasive submerged plants. So these plants are pretty widespread around lakes and river systems in the Pacific Northwest, and they are generally moved from water body to water body. Plant fragmentation on boat trailers. They grow rapidly, and they won't outcompete natives. They grow to the top of the surface of the water, and they make boat travel nearly impossible. This causes a major decrease of recreational benefits and community property values. You have all this topped out weed like in this picture, it just looks bad, and it, increased biomass production can cause eutrophication that'll cause algae blooms. There's just a number of factors that are negative about these invasive plants. So some of the main species of concern for invasive submerged plants are, number 1, Eurasian water milfoil. This is probably the one you've heard of mostly. It propagates via fragmentation. They can grow from the surface up to depths up to 25 feet. They grow monoculture mats all over. It's pretty widespread. Second is curly pondweed. This one propagates by a seed, also known as a tyrion. So it's a little bit different. They tend to be more early season plants. And this one's been starting to crop up in the past decade or two around, but it's also quite widespread. And then we also have hydrilla. It's not very common around here. It's more of like a southern plant, East Coast plant. Hopefully it doesn't come out here, but it's another species of concern that we're on the lookout for. And then the last one is parrot's feather, which is up in the corner, top right. Yeah, it's around. I've mostly found it in Oregon. And there's a few spots in the western Washington that it's found, but it's not quite as common, but can cause problems as well.
All right, now we're gonna snap into some floating leaf plants. So, bottom left, we have newfars. They look a little similar to your yellow floating heart, but just generally the leaves are a lot larger and usually protruding from the surface of the water a few inches. Then top left, we got white water lily. This is a problem. It's known in some places to be invasive. So, yeah, the main difference between that and the newfars and the yellow floating heart, when you look at the leaf structure, is the floating heart and the yellow and the newfars have like a cordate bottom of the leaf. It kind of looks like a heart. If you look at the white water lily, it kind of butts up and comes to a perfect triangle at the end, so you can kind of separate the different pads that way. Yeah, then obviously yellow floating heart, top right, looks similar to the newfars, only a little bit smaller leaves, usually don't protrude from the water. And then we got water shield, number 3. So at the bottom right of the screen, you can see the white water lilies on top, and then these smaller little pads underneath, those are water shield. And then finally, number 5, right in the center, is duckweed or lemon minor. They're very, very small lily pads that have a floating root structure. You know, one of those, they kind of look like little 4-leaf clovers kind of hang around the water a little bit, but you know, one of those little petals are maybe, you know, half or a quarter the size of a penny.
Next, we're going to talk about emergent vegetation. Here's one of our associates from probably about 10 years ago, riding our airboat, doing some emergent invasive control. So first off, there's cattails and bulrush. These are native plants. A lot of times they're good to have on your shoreline. Sometimes they become noxious, they want to be removed. Here's a marsh master. We have some cattails. There's also invasive emergent vegetation as well. Some common emergent plants are yellow flag iris. That's number 1 right up here, top left. And then we've got Phragmites right below it. Purple loosestrife is right here, number 3. And then number 4 is garden loosestrife. And then we have flowering rush, which is becoming an expanding problem in the Columbia Basin. It's well up and down the Conway River, all throughout the Columbia, and it started in Flathead Lakes. That's a species of concern that we're starting to deal with now.
All right, perfect. Now that everybody's an expert on invasive weed identification, we can skip to herbicide technologies. I guess kind of following this, we're going to go through different herbicide technologies, glossary terms that are going to be important later for understanding the talk. So for aquatic herbicides, we have algicides versus herbicides. Algicides are like copper or cyclomycin. They're used to control single-celled planktonic or filamentous algae. And then we have herbicides, which control vascular rooted plants. So they either burn it back like a contact, or they translocate the root. So that brings us to our next 2 definitions: contact versus systemic herbicides. Contact herbicides are things like diquat and aquathol, which burn back the leaves and the existing growth and don't translocate to the root system. Systemic herbicides will grow through the whole plant and give you multi-year control translocating through the roots. Then we have granular versus liquid. A granular formulation is crystalline or pellet form that's hard, so it's generally spread with, you know, a backpack blower or a hopper spreader. And these are kind of better targeted for zones with high water mixing because the solid formulation will sink, and, you know, upwelling and currents will push the concentrations out quick. Liquid, that's pretty self-explanatory. It's liquid formulation, so basically you can mix it in a tank with water and you spray it out of hoses like you see our fearless leader doing in the picture on the right. Surfactants, they're often required with a lot of herbicides, algicides. Basically a surfactant is just an agent which helps it stick to the plant or penetrate the tissue of the cells, which gives you a better efficacy and control. And then water use restrictions. So water use restrictions are associated with an application area after it's done. So it could be, stay out of the water for swimming for 24 hours or, 3-day irrigation restriction or something like that. But it's really important to follow those to a T and make sure everybody impacted is also aware.
Next, we're going to talk a little bit about pond or river nuisance aquatic weed management tactics. So there's a number of weeds, invasive and native, that are on the river. The most common are Eurasian water milfoil, curly pondweed, then you got a whole host of natives, Elodea, coontail, and there's plenty of native pondweed species out there. We found, working up on the river over the past few years, that the best management tactic is to treat with a contact herbicide, diquat and endothol. This will knock back all the vegetation. It's not species specific. It'll knock it all back very quickly. As a contact herbicide, you gotta treat year after year, because it just mows the top of the plants, leaving the roots intact. But we found this technique to meet the goals and budget of homeowners residing on the river. So this is generally the prescription we recommend to people when they want plant control to happen on the river. And then, so sometimes we just do specific invasive submersed plant control, and a lot of times that's Eurasian milfoil. There's a number of options that we had before 2019. Back in the day, it was mostly just contact herbicides, provided short-term relief. And then we used some sonar, which is fluoridone, but this was hard to do because it required a whole lake treatment, and it was a large contact exposure time, so it wasn't practical for budgets and just timing of treatments a lot of times. There was other technologies like 2,4-D, and then triclopyr has been around for about a decade or two. These provide longer term control. But we've noticed that a lot of hybrid plants have been starting to show up in the Northwest. So there's native water milfoil, and then there's invasive water milfoil, and they've hybridized to make these super strains. We've noticed that a lot of the 2,4-D and triclopyr has not been as efficient, and its efficacy has been reduced, so we haven't been able to see as much control with the older herbicides.
And then in 2018, ProcellaCOR was released to the market with US EPA approval. It's the first EPA registered herbicide with sole aquatic use in its mineral registration in 20 years or 30 years. So most, herbicides are, created and permitted for aquatic and terrestrial use, and generally lean towards being more designed for terrestrial use because the applications are just a lot wider range. But ProcellaCOR was different in that it was made just for aquatic use and only labeled for that. So it's a highly selective systemic herbicide with a really short exposure time. You only need hours to days for it to have activity in the plant cells. It's also got an EPA reduced risk classification, so it's about 100x or greater reduction in use rates versus older herbicides. So, a couple ounces of this stuff will kind of take the place of hundreds of pounds of older technologies, like 2,4-D, for instance. It's got a really good environmental tox profile, so, it doesn't cause, a lot of harm. It doesn't have, barely any restrictions on it, except for one advisory. So here's a mesocausing experiment. So before these herbicides are released to the market, they have to be, tested pretty vigorously to see what they do in controlled settings. So this is a trough at the experiment station, and on the bottom left right here, you'll see a nice healthy bush of EWM. On top right, you'll see American pondweed, and top left, there's another pondweed species. This is untreated water, and then this next picture, this is 2 months after, and 3 part per billion concentration is used at 6 hours of exposure. Here's Dr. Netherland up here, kind of excited about his experiment, but as you can see, the Eurasian water milfoil is nowhere to be seen, and then our native pondweed species are happy and intact, which is the kind of restoration we're looking for on a large scale.
So the greatest thing about ProcellaCOR is it has very low residue time and it's uptaken by the plants just incredibly quickly. This chart here kind of explains, comparing it to other herbicides, how quickly it is in the water and how quickly it's absorbed by the plants. They actually took apart the plant tissues and measured how much, herbicide is in the plant tissue and laid it out on this table. So the application of ProcellaCOR is a little bit different than other herbicides. They came up with a dosing unit called a prescription dose unit, a PDU. It's based on the size of plot and the type of species targeted, hybrid or Eurasian. So one PDU is about 2 to 3 ounces. One PDUs can replace about 200 pounds of granular. So it's a huge reduction in handling and labor for the applicators. It's recommended that you use a higher dose for hybrid. You can get away with a lower dose with duration. Often you have to, test it at a lab to see what kind of genetics the milfoil is ahead of time if you want to know that. It's a really unique system based on each lake, so it really varies. It varies on the size of plot, varies on the size of lake, how much water exchange there is, and if it's a hybrid or Eurasian milfoil, on how much you need to use.
All right, next we're going to kind of run through all of our major projects that we've done since the ProcellaCOR EPA registration 2018. I'm just going to run over a brief overview of the list, and then we're going to dive into each one of these projects and kind of show you, what we saw. So we have Morton Slough and Ponderay River 2018. We got Loon Lake, Washington, the hybrid milfoil study of 2019. Knoxon Reservoir, Montana, 2019. American Lake, Washington, 2019. Hayden Lake and Cocolala Lake in 2019. Vancouver Lake, Washington, 2020. And Osoyoos 2022, which will be next week.
The first operational treatment study for ProcellaCOR in the Pacific Northwest was on Morton Slough. This is on Lake Ponderay, just upriver from Ponderay County, past the dam, Bonner County, Idaho. They treated 3.5 acres. Done in 2018 before ProcellaCOR was officially registered. They got a special use permit. They went at it with 5 PDU per acre foot rates, which is a very large rate. Here's the cast of crew that was doing the studies. This is our boss, Terry McNabb. He's out there on our application boat doing the study. And that proved to be very successful as well. So the next project I'll talk about is this is the first project we were able to do in Washington State. This was right after it was approved. And we did a hybrid milfoil study on Loon Lake. Loon Lake is a nice 1,200 acre lake north of Spokane, about 30-40 minute drive. They've had a Eurasian water milfoil program there through about 1990, and we worked with them about 2007. After 2007, we had a different applicator that was treating with diaquat and 2,4-D mix, and they weren't having much success. So the Lake Association, they issued a new RFP, and they asked us back in 2016. We decided to develop a new plan to hit Eurasian water milfoil with triclopyr. But we did some DNA testing, and we showed that the majority of the plants on this lake were hybrid. So after that, they decided to form a lake management district. That basically means that they legally are allowed to tax everyone that lives on the lake, put it into a large fund, and use it on lake management activities. They also tapped into the Washington Department of Ecology grant program, and they were able to get about $100,000 to develop a program to treat this hybrid milfoil. So first off, we mapped the infestations, we collected plants, and we performed DNA analysis, and we shipped the plants off to NC State University, which was our partner. And they did some contact exposure time experiments to see how different herbicides would react on the plants and how well they would treat the plants. After numerous studies, we did our first operational treatment on July 2019. We were starting to write procedures on how to deal with hybrid populations. Once ProcellaCOR was approved, And this was July 9th, 2019. We treated 75 acres on the lake, basically the entire littoral zone. We made the application in about 6 hours. There's our crew treating, laying down some nice lines of herbicide.
And here's kind of the evaluation of that study. So, did a point intercept survey. So, pre-treatment data was collected at 52 locations within representative areas of the plot. As you can see, these little red kind of ticks inside all the treatment zones. That's an area where we had a piece of rope attached to a rake. You throw that rake out, you pull the rake in, and then you see and assess it for the density of milfoil apparent on the rake, and you give that a rating from 0 to 4. So there's another survey done 6 weeks post-treatment at those same exact spots, and then also 1 year post-treatment. And at 1 year post-treatment inside those plots, there's little to no milfoil at all. American Lake, this is another major project, kind of helped us figure a bunch of stuff out for ProcellaCOR. American Lake's in the Seattle area. Eurasian water milfoil is a major problem in the lake. The lake's about 1,200 acres. In 2017 to 2018, they issued an integrated aquatic plant management planning grant, and this resulted in the treatment of 166 acres with ProcellaCOR in August of 2019. We had excellent results in 2019. So here is a map of American Lake, and then as you can see in the orange area is the treatment zones that were treated throughout the entire lake. And this is just a really cool photographic, kind of a stark image of the efficacy of this technology. But on the left side of the public program, you can see pre-treatment 2020. Milfoil is canopied out pretty much everywhere you can see. And then the right side of the public program, 1 year post-treatment, it's not in the fall. This is a picture taken in the summer, people on the beach. You can just see the substrate rocks, so some pretty good results.
The first treatment we did in Montana was on the Knoxon Reservoir. This is upstream from Lake Pend Oreille on the Clark Fork River. We did about 34 acres there, 5 PDUs per acre foot. And this was a successful treatment. We did some post-treatment surveys and pre-treatment surveys, and we reduced the Eurasian water milfoil by 93%. There's another survey. The native plants were able to rebound. And yeah, also another thing about this treatment was it proved that ProcellaCOR worked in somewhat flowing water because it was on a run-of-a-river reservoir. So that was another success for ProcellaCOR on this project.
All right, now we're going to switch gears to Hayden Lake, Idaho, ProcellaCOR 2019. Hayden Lake, 6,800 acre lake, just north of Coeur d'Alene. We treated 93 acres on it, as you can see represented by those yellow kind of polygons on the lake. The treatment plots kind of varied in this study from large enclosed bays to narrow steep shorelines, which is important because it gives you a kind of wider range of areas of usage for the chemical where it's efficient, and that's kind of just piggybacking off of what we found out in Montana and Knoxon, where this chemical can work in high exchange rates of water. So the treatment program was part of ISDA's program, and the ISDA evaluated it in the summer of 2020. And this is, a quote right from their mouth, but, we treated 90+ acres of hybrid milfoil with ProcellaCOR in 2019, and, for Hayden, a total of 215 survey points within treatment zone areas where it says the best news to come out of these treatment point evaluations was there was no presence of EWM at these points 1 year after treatment. Next, we have Vancouver Lake, Washington. Another one in the Seattle kind of area, 2,700 acre lake connected to the Columbia River. It's got a tidal influence, which is a major problem for trying to keep plants out because it can kind of move stuff around. Heavy Eurasian water milfoil problem, and also just a very economically important lake for the area. Regattas, as shown in this picture on the right, is kind of the regatta course, generates about $2 million locally for the economy. So it's really important for everybody's livelihood around there. And if there's a lake that can't support that, other people could suffer. So treated in July of 2020, We utilized 3 application boats, treated 700 acres in the main lake, and then treated 15 acres in the Flushing Channel. Project took about a day and a half to do. So yeah, this is Terry on the right, banging on the airboat. We treated 700 acres of EWM. Post-treatment, results at the end of the season, no EWM found at any of the Washington Department of Fish and Wildlife survey points. No milfoil observed.
Alright, next is the Okanagan chain of lakes. This is a lake that straddles the border, so half of it's in Canada, half of it's in the United States. We're gonna be going up there next week to do a good treatment up there. They're actually trying to get ProcellaCOR registered in Canada right now, so this is gonna be a bit of a trial run. They might invite some Canadian representatives to observe our treatment and the results. So that's another good treatment that we have upcoming on our schedule to ProcellaCOR on Eurasian water milfoil control.
So here's just a summary of the technology. ProcellaCOR, excellent tool for selective Eurasian and hybrid milfoil control. Has a fast plant accumulation time, which allows for use in high water exchange environments. There's a very good tox profile, no water use restrictions except a manageable 24-hour irrigation advisory. And, has an easy to use system. 200 PDU containers has replaced thousands of pounds of granular product.
Right, the next invasive plant we're gonna talk about is curly pondweed. This is a bit of a different plant than Eurasian water milfoil. Its distribution the past decade or two has really increased in the Pacific Northwest. It has quite a unique life cycle. It's not like any other submerged plant found in the Pacific Northwest. So it begins to grow under the ice a long time before the other submerged plants begin to emerge. It hits full bloom in the late spring and early summer, and it really begins to die back for the season by mid to late summer. It spreads via seeds known as chirions, and these begin to fall off, right around the mid to late summertime period when they start to die back, and that's how it spreads. As you can see, this is the chart that shows you its life cycle. So it starts out under the ice, little saplings, and then right when the ice comes off, it really starts to shoot up as it gets a little bit warmer out, and it's already topping out by the end of the spring and early summer. Then as you get into summer, it starts to drop its seeds, and it really increases its seed bank, and then it dies off quickly. And then, during the fall, the process starts again. You got a large seed bank, so the numbers are increased, and it starts the process over again on the ice.
All right. Now that we know what curly leaf is, we're going to talk about some treatment options for that invasive weed. So we have contact herbicides, Aquatic and ProcellaCOR. These are very effective, provide, short-term relief. They're fast acting, so you can treat and it'll knock the plants down in a week or two. But you just gotta treat every year basically. Then we have systemic herbicide Sonar. Sonar, we have to, that same problem, we have a long contact exposure time, so you have to be in an area where you can keep the concentration up, or you have to do a very large treatment area or the whole lake treatment to have good results. Then our newer one is Galleon. We've been working on this with some new studies at Moon Lake this season. This is a systemic herbicide. What we found out about Galleon is treatment cost per acre decreases as you treat a larger number of acres. So in saying that, you can use lower concentrations to control areas, if you have larger areas. So yeah, next slide. This is just kind of a graph that represents kind of what I was just talking about. So on the x-axis, you will see treatment plot in acres, and on the y-axis, you'll see Galleon concentration in parts per billion. So we can see this relationship, how as the treatment plot increases, the lower concentration is needed for control. I also should mention that this is a reduced risk herbicide, so this is kind of the EPA classification that ProcellaCOR is in, where it's pretty tame to be using.
All right, next we'll talk a little bit about irrigation water. So sometimes you have to treat water with irrigation, and my favorite herbicide to use is Aquatechnex. It has no irrigation restriction, so yeah, you can treat anywhere that you need to irrigate with no effect on the plants if you're pumping the water out. You can also use codeine crystal or codeine, and this is a copper-based herbicide. Fortunately, the Washington ecology permit it's not registered in Washington. Copper isn't, so you can't use it in permitted waters. You can use it in a pond that is less than 5 acres with no outflow. So you still can use it, but unfortunately you can't use it in bigger lake environments. You can also use sonar under some conditions, but there's some contact exposure issues there, and there's some irrigation restrictions that can be limiting in some conditions. But my favorite is Aquatechnex.
Okay, so emergent vegetation treatment options. We have ClearCast, which is seed pearl formulation of Myzalox. This is excellent on all emergent applications. So on the right top, you can see kind of what ClearCast will do to a patch of cattails. On the left is the same area. They're growing great. On the right, post-application, 1 month, they're all smoked. Glyphosate is still one of the cheapest and one of the good technologies to use. It's a systemic herbicide. It's cheap. It's a great option for if you're looking at a budget. Both of these you need to include aquatic surfactant to the mix. So the surfactant in this application is going to help it stick to the leaves and then penetrate the plant tissue to increase the control. These herbicides also work really good on floating vegetation, lily pads. So if you're dealing with fragrant water lily, ClearCast and glyphosate is a really good technology to use.
All right, we're going to switch gears a little bit and talk about algae. We do a considerable amount of work doing algae and phosphorus mitigation control. So we thought we'd talk about it a little bit at the end of our presentation here. So a few different types of algae. First type is planktonic algae. These are single-celled organisms, plants basically, that are suspended in the water column. There's a few different types of planktonic algae. So that'd be green algae, diatoms, and then cyanobacteria. Cyanobacteria is harmful algae blooms that can typically make you sick, and we're trying to go after. And these kind of planktonic algae, they can regulate their position in the water column. So it doesn't form mats, but it makes the water look green. You can see it microscopically in the water floating around.
I'm going to talk about golden algae a little bit yet. It's an emerging threat. So golden algae was first noticed in Texas, and it's native to Scandinavia. It's spread east of Florida, west Arizona, and California. It produces toxins that stop the transfer of oxygen across the gills of fish. So as you can see in this middle picture, it's a reservoir with a bunch of dead fish in it. Generally, you don't know you have this problem until you wake up in the morning and you go to the pond and every fish is dead, and that's usually the telltale sign. So, yeah.
Next is filamentous algae. So this is when you really see the mats on top of the body of water. This is when cells divide but remain attached. Generally the mats, they'll form on the lake bottom and then they'll lift when the gases are produced. Some can secrete mucus that protects cells from algicides, so sometimes they're a little tough to treat. You have to use a little bit hardier algicide when you're trying to treat this. Typically, chelated copper is best. Unfortunately, you can't use that in permitted waters, but on ponds we can use copper, no problem.
All right, here's a macroalgae. This is Car nitella, which is often mistaken for a vascular rooted plant, but it's actually just a really big algae. So, it's also called muskgrass, but it can be mistaken for vascular plants. Generally, the plant has calcium buildup on it. So, if you can see the picture on the right, there's a little bit of white kind of growing on it. That'll be a telltale that you have Car nitella. It can be a beneficial plant when aesthetics are the main area of concern, because it only grows about 3 to 6 inches off the bottom of the lake, isn't going to top out, and kind of takes the space up that some of those nuisance and noxious aquatic weeds would otherwise be in. But yeah, if you basically pick it up and squeeze it in between your fingers, you're going to smell like a little musky kind of thing, and that's why it's called muskgrass. And also, as you squeeze it, you will feel the cells pop in between your fingers. They're just really large cells. So if you squeeze it and it pops, it's probably muskrat.
And now we're going to go into talking about actual harmful algae blooms, known as HABs. These are caused by cyanobacteria, as I talked about, as a planktonic algae before. This is just kind of a funny photo our boss took. He saw an advertisement. You know, it's the Washington Monument reflecting pool. It's got a huge bloom going on. So a few things about harmful algae blooms. They produce acute toxins, liver toxins, nervous system toxins. You know, they can be harmful to waterfowl and other aquatic life. They have potential human health impacts. You know, this photo was taken on Lake Erie by Toledo, Idaho, near their water intake. So, you know, there's links between HABs and ALS disease, and there, you know, you can get these toxins via airborne toxins. Exposure can be from potable water supply. So this is kind of a concern, and it seems to be popping up more than often. You know, the climate's heating up, and we're developing more. There's more phosphorus running in the water, so this is becoming more of a problem as we see over time.
So now that we know the problem, let's talk about control. So we're going to talk about reactive harmful algal bloom treatments. So U.S. EPA registered algicides can be used to provide relief. Copper, as we've talked about, there's permit issues in the state of Washington, but peroxide can be permitted to do larger treatment zones in permitted areas. The first picture on the left is the Maple Valley Ironman event. So a toxic algae bloom threatened to cancel the swim in the triathlon. So we got in there, we treated it with a peroxide algicide and provided the relief and kept the thing going. You know, peroxide is just like, it's similar to hydrogen peroxide, so it's very innocuous and safe. You know, if you put this stuff in the water, it precipitates out in about 90 seconds, and there's no trace of the chems at all. The second picture is Utah Lake, which is a 60,000 acre lake just south of Salt Lake, and we were doing peroxide algicide treatments in a bunch of the state parks there. We continued to do this last season and then a little bit this season too.
So the next way we can prevent harmful algae blooms is a proactive way, and this is doing nutrient inactivation. So phosphorus is the #1 culprit fueling HABs. You know, it causes eutrophication, and you know, this is what fuels cyanobacteria blooms. So if you can control phosphorus, you can control the blooms on a more long-term scale.
Aluminum sulfate. This is kind of the traditional or oldest technology for proactive harmful algal bloom mitigation techniques. Here's just a canyon lake, which our Southern California operations kind of handle, but we've been doing that there for quite some time. So basically we'll give you a little background on some other things too. In 2010, the Southern California operations began an annual management contract for 9 regional parks, which had 15 lakes. They were old golf courses, which were turned into parks. They were highly eutrophic, and you know, the biggest concern was half the year the ponds were fed with reclaimed water or gray water. So that's already really high in nutrients, so it's just kind of a scenario for disastrous algal blooms right from the gate. Alum does not perform well in high pHs. These lakes in really Southern California, a lot of them have really high pHs, and alum just wasn't cutting it anymore, so we were looking for alternatives. Here's kind of just the relationship between alum and phosphorus capture. It's not as effective in high pHs. Southern California lakes with cyanobacteria blooms can have pHs in the range that is problematic. So we needed a newer technology to overcome the limitation.
Right, so this new technology is called Utrasort. It's formerly known as ProcellaCOR. So this was brought over from Australia by the Seaco Corporation about 10 years ago. The primary difference between phoslock and alum is phoslock captures the free reactive phosphorus, forms a new compound not biologically available. And it doesn't impact the performance of phosphorus sequestration. It doesn't change water quality, doesn't require a buffer. And also there's less monitoring requirement. In Washington State, the Department of Ecology makes you monitor a lot more in alum because you could crash the pH in a lake. Nutrisorb will not do this. It's just a lot better because it actually permanently binds the free reactive phosphorus, making it unavailable, and it's just a lot more of a long-term solution. This was the first time we used phoslock, now known as Nutrisorb, in Washington State. This is Lake Lorraine. It's on the west side. As you can see, after 1 year of treatment, the water's green in 2011, and then 2012, it's back to its blue state. No more blue-green algae blooms, and the second depth was increased.
Here's another kind of case study for the ProcellaCOR technology. This is Kitsap Lake in Washington. It's a 245-acre lake west of Seattle. It's had toxic algae closures for several years. So the community got together, they issued an RFP for a phosphorus management plan in 2019. We competed for the RFP and were selected, and it was completed in fall of 2019. After community input, the program was implemented. We got on the water in summer of 2020, and we selected ProcellaCOR technology to be the primary tool in algae mitigation. So here's just some shots. I'm sorry, they're pretty grainy photos, but this is just kind of how the operation goes down. We have a large barge, and then we fork out the pallets of product and have a hopper system on the boat that allows us to displace the chemical. So here's just an aerial shot of what the barge looks like. We're doing a surface application here. Surface applications are generally targeting phosphorus that is in the water column, and then if you inject it, you're looking at to get hypolignetic phosphorus. So project operations, 2020, first year of treatment, June treatment, we targeted the phosphorus in the water column, like I mentioned, by doing a surface spray, and then later on we did injection to target the hypolignetic phosphorus before turnover. So, yeah, basically we put in around 60,000 pounds of this stuff the first year, and about a half of that the next year. And we have some photos to show you what that kind of stuff will do.
So here's just a little chart showing the Secchi depth water clarity. So a Secchi disc is a little disc you drop down, and when you can't see it, that's how much the Secchi depth quality is. So as you can see, the historical, it's not very deep, has lots of algae blooms in the past. After 1 year of treatment, we saw 3 times of an improvement on the depth that you could drop down that Secchi disc. And then after a second year of treatment, it even improved times 4. So great improvement on Kitsap Lake.
Here's just the hypolignetic phosphorus in micrograms per liter. On the top of the graph in green, you'll see the 2020 kind of levels that we're at. So we're cresting into the 600 and even 700 range of total phosphorus in micrograms per liter in 2020. And then we have the 2021 results, where basically, maybe we hit about 100 micrograms per liter of phosphorus once, but compared to 600 or 700, that's a pretty stark difference.
So as a result, in August 2021, they had excellent water clarity. And actually, the water clarity made all the aquatic plant life thrive in the lake. So yeah, they now have noxious weeds that they're trying to deal with, and they're probably going to be doing some aquatic plant harvesting and other treatments to help maintain their beneficial uses. Now they have just an explosion of aquatic life because they now have enough light for photosynthesis as compared to when there was no light due to the harmful algae blooms. You can see the stark difference before and after photos. It's just green, nasty water. Now the water is totally clear. Yeah. So that was our presentation. We'll open it up for questions. Wanted to thank the Conroe County Noxious Weed Board for letting us give this presentation. Hopefully we'll be there next year in person without the COVID.
All right, thank you. If anybody online has any questions, they can put it in the Q&A and he'll stay on and he can answer those for you, I think. So, but I can run around in person here and, all right.
Yeah, good morning. Thank you for your presentation. I'm surprised I didn't hear much about potential risks to the ecosystem or humans long term, or how much data there is about that.
For what herbicide or algaecide specifically, or just in total?
Well, it wasn't mentioned on any of them, so I guess the ProcellaCOR, if that's the name
Yeah,
of it,
so I mean,
would
I
be a
guess
place to
we
start.
mentioned water use restrictions. So with all these, there's an EPA threshold for what they deem safe for irrigation, for people, for dogs, and each one of those labels has those specifications on it, and you're legally obligated to do proper notification and business and residential notices to let stakeholders know, and if they want to opt out from being involved with it, they can, and that's kind of why that due process is set up.
The EPA, they spend many years registering these herbicides and doing studies on them, and they produce safety data sheets to basically show what the tox levels are. And yeah, they've been studied by the EPA for many years before they're approved.
Great, thank you. Any other questions in the room?
Commercial on TV for medication.
Oh, I see one back there.
Good morning. So, the question I have is areas of running water, how effective are these, chemicals on milfoil when there's, moving water?
Sorry, I had a little trouble hearing you. So the question is, how effective are the technologies in moving water?
Yes.
Okay, so it really depends on which herbicide, like we were talking about ProcellaCOR, that has the faster the plant accumulation factor is for the herbicide, the more efficient it's gonna work in running water. So ProcellaCOR, you could use that in a river and it could be uptaken, but if you wanted to try to use a fluoridone or, a galleon, those have a really long contact exposure time, so it's not gonna move in worth water. So it kind of just really depends on which herbicide, they're all different.
So the contact herbicides, diclot and indofol, also known as Volcaic, they have about a 24-hour contact exposure time. So you can use them somewhat in a flowing environment. Obviously, if the water's flowing, like if you can see the water flowing, it's not gonna work as well. But the contact herbicides that just knock back every species of weed, they will work to some degree in flowing water.
Great, thank you. I've got another question here.
Yes. If you had a body of water with both curly leaf pondweed and milfoil, would you have to use 2 herbicides, or would ProcellaCOR actually knock down both of them?
ProcellaCOR, it doesn't work on pondweeds at all, so it's selective to Myrinophyllum, which is milfoil species. It's selective to yellow floating bark, and then it's selective to Hydrilla tiscalata. So ProcellaCOR is only gonna get those. So to answer your question in short, you probably want to use, if you want to go with the systemic herbicide, you'd have to use 2 different ones to treat both milfoil and curly bark. There is some efficacy treating both with galleon, but it's not as good. Yeah.